Hey, what's going on, everyone? Adam the Tutor here, coming at you with the final part of our mass spring system problem. Now, basically, let me just refresh your memory as to what we were going after in this. Let's see, okay. So if you chose the, well, there really should be a unit step function there, but if you chose this guy, right, our second case, right, for our function, this number 2 that's underlined in green here. If you chose this as your driving force, are there any special phenomenon that could occur? Well, basically what we're going to do is we're going to look at omega, little omega here, not big omega. Let me get a different color here. We're going to look at this guy right here, right? This guy. We're going to look and we're going to try to find the value of this omega that will maximize, well, basically the amplitude. Because what we want to do is we want to try to maximize this amplitude, which basically means that we're going to get the largest displacement of the mass, right? So if you'll notice, what I've done here is I've rewritten the particular solution xp, or x sub p of t, and I've broken it up accordingly, or according to these two different coefficients, right? And what we're going to do is we're going to call these guys, this one will be d1 of omega, right? So this is a function of little omega. And let's see, let me get, well, let's do pink. And this one is d2 of omega, okay? So, let me just move back to red. So basically what we want to do is we want to find the amplitude, or we want to find the omega that maximizes these functions, right? Because then that will maximize our displacement. Okay, so what we're going to do is we're going to take the derivative, right? I'm going to do this first one first, then with respect to omega, and when omega equals omega, what we'll call omega res, then this guy will be equal to 0. Now, what is omega res? Well, this right here is the resonant frequency. Okay? So, let's go ahead and find it for this system. So, we're going to have the derivative with respect to omega of omega minus gamma minus big omega over big omega squared plus omega minus gamma squared, right? So we'll have the derivative of the top, which is just 1, and then times the bottom, which is right there. And then we'll have minus, normally it'd be a plus, but we're going to have a minus when we take the derivative of the bottom. And then we're going to have this guy, right, our denominator. And then that's going to be squared. And then we're going to have times, and then we'll have times 2 omega minus gamma, and then times the top. So it's going to get a little messy here, but it'll be okay. Minus omega. Right? Okay. So at this point, what we want to do now is we want to set this guy equal to 0. Okay? So, automatically we can multiply through by this guy right here, and then add this term to both sides. So what we're going to get when we do that is we're going to have omega squared plus omega minus gamma quantity squared is equal to 2 omega minus gamma squared, and then we're going to have minus 2 omega, and then omega minus gamma, right? Well, right off the bat, this guy will cancel with one of those, and then so we'll have 0 is equal to, well, we're going to have omega naught squared, and then we're going to have, okay, so we're going to have a 2 gamma omega, and then here we're going to have a minus 2 big omega times little omega. So basically what we're going to have then is we're going to have a plus 2, right? And then we're going to have gamma, or well, here, let me just write it out instead of trying to do it all in my head. Here we go. Okay, so let's just write it all out, then we'll group. Okay, so then minus 2 gamma times omega plus gamma squared minus 2 omega, or big omega, little omega, and then plus 2 big omega times gamma. Well, now we can rearrange this, and we'll have omega squared. We have a minus 2 gamma little omega minus 2, so it'll be minus 2 gamma plus omega little omega, and then plus gamma squared plus 2 omega gamma, right? And now at this point we can use the quadratic formula to solve for this guy. So we'll have minus b 2 gamma plus omega plus minus square root, so it'll be 4, and then gamma plus omega squared. Oh, did I did not subtract that. Did I? Big omega squared. No, I did not. So minus omega squared minus omega squared. Okay. So, and now what we should get is, okay, so we have b, and then we have minus, or well, b squared here, minus 4, and then a is 1, and then we need c, which is gamma squared plus 2 gamma, or 2 omega gamma, and then we'll have minus big omega squared. Okay. And then that is going to be over 2a, but a is just 1, right? Okay, well, automatically, the 2, right, we can bring a 4 out of the square root, well, we can bring a 2 out of the square root, and then that will cancel all the 2's, so then we'll have gamma plus omega plus or minus, okay, so we have a gamma squared here minus a gamma squared here. We have an omega squared here, and then we have a plus, so we have plus, we'll have plus omega squared here, we'll have a plus omega squared here, so it'll be a plus 2 omega squared, and then we have plus, we'll have plus 2 gamma omega, which will cancel out with this guy, so we'll be left with plus 2 omega squared. Okay? And, right, we don't need that. Okay, so let me just check to make sure. Okay, so 2 comes out, cancels with that 2. We have this guy, plus minus. Okay, so gamma squared cancels with gamma squared. We have plus omega squared here. We have plus omega squared here. That's this guy. And then we have 2 gamma omega minus 2 gamma omega. Okay, so there we go. So this right here is the resonant frequency. And notice there are actually 2, right? Because we could choose plus or minus. And, you know, if we wanted to simplify it a little bit further, we have that, and then plus minus root 2 omega gamma, and then plus omega, and then 1 plus minus root 2. Right, so this is our omega res for d1 omega. And, you know, you can go through the same process for the second one. I mean, really, it's actually just plugging in here. We can do it right quick. It's really just plugging in a plus sign here. It's really the only difference. So then we'd have plus, 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 and then let's see, okay, so plus, and then so this becomes a plus. This becomes, okay, that stays the same, but then we have a minus on this guy, right? That omega squared is still minus. Alright, so let me check to make sure, right? Okay, that plus corresponds to that plus, and then we have this plus, which would correspond to a negative there, right? So then what we'll have is we have, let's see, okay, so that would be a plus 2 gamma omega, and then a minus 2 gamma big omega. Or, I'm sorry, no, I needed it right here. So plus 2, okay, and then we need a minus right here, and for here, this should still be good. We'd have plus 2 gamma, minus 2. So then we'd need a minus here, and then we need a plus there, right? Okay, and then so then that would be, okay, so we'd still have our minus plus here, right? And then we'd have, okay, so we'd still have our minus plus here as well. And then, let's see here, so then this 2 gamma, this would get a minus sign. And, right, okay. And then, so this would be minus plus, and everything should still hold. If we had a minus sign, we'd still get gamma squared, which would cancel out. And this time, this one should be, actually, hold on, I think there should be a minus sign here. Let me go back to this step right here. So we have plus 2 gamma little omega, and okay, so we're good. I mean, you know, basically you're gonna get this same thing, but there's gonna be some different pluses and minuses, right? And you know, so it's really not too bad. I'll go ahead and leave it to you to figure out. But basically, this is kind of the process, and this is just for this first, you know, d1 of omega, right? So, well, actually, I started it. Maybe I should just go ahead and finish it. Okay. Yeah. Okay. So let's do it. Let's keep going here. Okay. So basically, we'd have plus minus. Yeah. So no, actually, this was right. Yeah. So I factored out a minus 2, which would flip that. Yeah. No. So actually, no. This is good. This is actually right. So this would be, if I chose the plus sign here, then that would be, so we'd have a negative gamma here, right? So minus, plus, minus, plus. If we chose the plus sign, or if we chose the bottom sign, basically, that would correspond to D1. So, bottom sign. Right, and if you selected the top sign, then it would maximize d sub 2 of omega. So, essentially, what we've done here is we found the resonant frequencies for both of these amplitudes, right? D1 of omega and D2 of omega. So now, you know, let's kind of look at something, right? So this is with dampening, right? Well, what about in the case, what if this was the case, right? So no dampening. Well, then basically what we'd have then is that omega res would be equal to minus plus gamma. Well, this would be 0. So these would be our two resonant frequencies, right? It would just be gamma, which should make sense considering that our original undampened frequency was just gamma. And, you know, what would gamma be in this case? Sorry, I showed you my YouTube page there. So what would gamma be in this case? Well, we'd have omega res would be equal to minus plus gamma. Well, gamma was just omega naught squared minus little gamma over 2, but little gamma over 2 is 0. So then it would just be this, right? Which is exactly what we'd expect, right? If we oscillate the mass, if we attach a forcing function to it that's sinusoidal in nature, and we apply the same frequency to our driven oscillator, now we're going to get a resonance phenomenon, right? So that is basically it. And I know I kind of teetle-tottled there on the whether or not I wanted to do d sub 2 omega. I'm just trying to figure out my signs. Signs are my biggest enemy. But, so yeah, I mean, that's basically it. So we have solved completely this mass spring system. And it was a pretty fun problem. Oh, well, you know, for me anyway. Hopefully for you too. So that's going to do it for this video. I hope you enjoyed this series. And, you know, if you have some other problems that you'd like to see me solve, or, you know, if you just, you know, say, hey, you know, come up with this kind of problem, I will do my best and make a video on it. And yeah, so I mean, if you have any questions, comments, or concerns about anything presented in the video, feel free to drop a comment in the comment section below, and I will see you in the next video. Thanks for watching.